Hey all, this is the homework 3.5 tutorial video. I'm not going to do every single one of them because that video would just get to be kind of monotonous. However, I will upload all of my solutions as soon as I've done each of the problems to my website. So let's go through the first one. So I noticed this one has an x and a y in the first equation, and then a y and a z in the second, and then all three variables in the last one. And because my goal is to eventually get to the point where I just have two equations with two variables, I'm just gonna take one of these and not use them and just set it aside. I personally really like the first one just because it looks nice and simple. So let's just put it off to the side. We'll use that later. Right now, instead, let's use the second and third equation. Let's get to the point, let's use these two equations to cancel out z, because if I cancel out z in these two, I can use that equation with one because it only has y. So let's do that. Plus 6y plus z equals 20. I know I'm out of order. It's just so I can line my labels up so I can see it a little bit easier. So I notice if I multiply everything first equation by 4, those z's will cancel really nicely for me. So let's do that. I then get 4x plus 24y plus 4z equals 80. Beautiful. X doesn't cancel. Y doesn't cancel. But my z's cancel. And I'm left with 100. Yes, there's some big numbers in equation. I'm not super worried about it right now. Now that I have this equation in terms of y, I can bring it back up here and use it with the equation that I set aside originally. And now I can use those two equations to get one of my missing variables. I see the easiest piece out here would probably be that x, so I'm going to multiply everything in my first by negative 4, negative 4x, negative 8y, and negative 48. Add those back down. Those become 18y. That becomes a number that I can't do off of the top of my head, so I have to get a calculator. Yes, even math teachers use calculators quite often, actually. I've told you before, mathematicians are lazy. We don't like doing hard work when we don't have to. So, 57. Divide both sides, you get y equals, and then I believe 57 divided by 19 is just 3. I now have a y variable. Sweet. I'm going to box that so I remember where I put it. Now let's use that in our two variable equations to get another one. I'm going to put it back into this one just because it looks simple enough to solve for. Do x plus 2 outside of 3 equals 12. X equals 6. 2 out of 3 ain't bad, but it's just not what we quite need. So let's plug both of those back into this equation. And I get 6 plus 6 times 3 plus z equals 20. I always try to plug it back into an equation where the z variable doesn't, or I'm sorry, not the z variable, the variable that I'm solving for doesn't have a coefficient in front of it, because by doing that, then all I have to worry about is these numbers over here. So I get 18 and 6 is 24. I subtract that to the other side. 20 minus 24 is negative 4. And I now have an x and a y and a z. Bring all of those together, and I get the coordinate point 6, 3, negative 4. And that should be my solution for the first one. One of the other ones I noticed that we were having a hard time with was number 4. So with this one, it's not quite as nice as number 1. We don't start off having something that we can just set aside immediately. We're going to have to do that full process where we go through simplifying them down twice. So the first two equations I'm going to take and put aside are 2r and 4r equations. 2r, this should be an s, plus 3s minus 4t equals 20. 4r minus s plus 5t equals 13. I'm going to multiply everything in this first equation by, actually no I'm not, because I see that the s's cancel out a little bit nicer here. I'm not going to multiply that first one. I'm going to multiply the second one. So we have the top one, we're leaving that alone, and then we got 12r minus 3s plus 15t equals 39. Now we can add them down, because now I see that my s's cancel. I get 14r plus 11t equals 59. Now that I have an equation with two variables, I'm just going to set it aside. I don't need it for the moment, so let's bring that back up here. That's one of my first equations. Okay. Now I need to do the same thing again, but with two other equations. So I used 1 and 2, so I can't use those again in the same pair. But since I'm trying to get rid of s, it's going to be really easy if I use 2 and 3. So I'm going to take those two as my second set of equations. Put a little divider here so we know. Bring those two down, we get 4r minus s plus t. There's a lot of rewriting the same thing over, but if you want to say I just say wasting the ink and doing it. It helps me stay organized, to keep in things that I need. Let's get this moved up a little bit so you can see it. Alright. I notice if I want to cancel that s out, it's easy enough to just multiply the first equation by positive 2. I get 8r minus 2s plus 10t equals 26. Add them down like we're used to. I get 11r. I get positive 14t equals 41. Sweet, I have another equation. I'm going to bring that one up here. Let's scroll out so you can see the whole page if I can. Is it not going to let me zoom out? It is not. I cannot zoom out to show you this any better. I'll do my best to try and keep it kind of all on one page here. There it is. Alright, so we bring that up. We get 11r plus 14t equals 41. There's not a real nice way to go about solving this one, just because the numbers are so big. So all we're going to have to do is the normal elimination, and we're just going to have to work with some big numbers. So I grab my calculator here. I'm going to put it here so you can kind of see what I'm doing. So I'm going to multiply everything in this first equation. There's not really a great least common multiple of 11 and 14, so I'm probably just going to use those big numbers and multiply everything in the first equation. Let's just cancel out our r's because they're closer. Let's do this one by negative 11, and we'll just do this one by 41. So we have negative 11 times 41. The nice thing is once you've done it once, you've kind of done it enough. So negative 451r, and then 11 times 11 is 121. Yep. Negative 121t, 11 times 59, negative 649. Then we've got positive 451r, 41 times 14, positive 574t, and 41 times 41. Why did I multiply that times 41? Nope. This should not have been 41. I had a moment. It should have been 14. Please ignore this line. This is 41r for 41r. However, it's then 14 times 14, which is 196. That looks a lot better. So plus 196t, and then 14 times 41, which is 74. That's what I should have been doing. Alright, now I can eliminate the same way I'm used to. My r's cancel out. I get 196 minus 21. I get 75t equals 570 minus 669, negative 75. Thank goodness all these gross big numbers end up coming out nicely. I get t equals negative 1. From there, I can plug things back in. Once you get to this variable, this is the hardest step, but once it's kind of homeward bound from there. So let's take this, plug it back into one of these nice equations that we were working with a minute ago, as nice as they can be with these large numbers. Let's do 14r plus 11 times negative 1 equals 59. You get 14r equals 59 minus 11, which is 48. R equals, I think it's 3, but I'm going to double check on that. Something's not right here. Did I do my basic subtraction right? Yes, I did, so why doesn't this come out nicely? I caught my... Did you, when I made this issue of 11, which I should have then added over, so when I add that over, I actually get 70. 70 divided by 14 is 5. So we get r equals positive 5. That worked out a lot better. Now we're going to plug it back into those 3 variable equations that we were originally working with. 2, 5, we don't know what s is, minus 4, times that t, 20. Sweet. 10, 3s, positive 4, 20. I realize you can't see what I'm doing because I got all excited and got off the screen. 3s equals 20 minus 14 is 6. S equals 2. I now see why everyone had issues, because you could see that I also struggled. A lot of you get confused when they're not x, y, and z. Q, R, S, T. So we go 5, 2, negative 1. They should always just go in alphabetical order. Alright, your final answer for number 4 is 5, 2, negative 1. One of the other examples that I would do is number 5, because it has an unusual solution. So, let's go about it the same way we usually. I think just because these are all pretty nice x, I like to get rid of those first. So out of the x by using first two, I'm gonna the first step that I use, which is just moving them down. This is actually gonna multiply this one. 4, I move it down here. I'm gonna multiply this entire thing by negative 2. So negative 2x, negative 4y, pop 8z, negative 6. I always do those, and I'm gonna just add down. Negative 5y plus z, negative 7. Let's put that away from it. Negative 5y plus 9, negative 7. I'm going to jump back up here. I'm going to use the second two equations. Equally easy to get rid of x and next to. Copy that second now. 4x by negative 7z, negative 8. Multiply this one by negative 4 to add it down so I don't have to re-roll equation. Negative 4x, negative 8y, positive 16z. And then negative 12. Down. Negative 5y. Let's bump up here. Plus and z. Negative 20. Bring that up. Over. Negative 5y plus 9z. Negative. Alright, before we go any farther and start trying to eliminate things, the first thing I want you to do right away is that you have the same things left side. So if I multiply negative 1 or multiply the top by 1, everything over here is cancel. That's going to be an issue. So instead, what I'm going to do is I'm just going to set their solutions to each other. Because equal on this side, they should be equal on that side. Except now I have an issue. Now a negative 7 equals negative 20. Negative 7 equal negative 20. Never. So because this is not a true statement, we got to the point where these two do not have an intersection. There's nowhere where they cross. So we can right here just write no solution, because if they don't have intersection point, that means your two planes or your three planes are not crossing the way that they should, the way that they have that point that they all go through that we. So final answer for number 5. No solution. We actually really like when this happens, because we don't have to do work. We can just write no solution. I'm not going to go through all of problem 3 because it ends up being very similar. It doesn't have no solution, but it ends up having many solutions. And you get to a point in the problem where something very similar happens, where a lot of things cancel out. Don't get frazzled by this. If something like this happens, first thing is check your work, make sure you didn't make any arithmetic errors. But it's totally okay for this to happen. We can have no solution, infinitely many solutions. These things happen a lot because it's hard to get 3 separate objects to intersect the way that we want them to every time. If you have more questions on this, let me know. I'd be happy to help.